Today's lecture is regarding the refraction through a lens. Now, till today we have discussed refraction through a glass slab and a prism. Now you see these two devices, optical devices, that is a glass slab and a prism, are actually plane refracting surfaces. And in case of the glass slab, the refracting surfaces are parallel to each other, or they are at an angle of 90 degree to each other. Whereas in case of a prism, the refracting surfaces are inclined at an angle. But when we talk about a lens is a refracting medium which is made up of two transparent surfaces, 1 and 2. Two transparent surfaces, right? Now, this lens which I am having is a biconvex or a double convex lens, because both the surfaces are spherical and are bulging outwards just like this lens. Okay? The lens can also be a concave lens. Now you can see the difference. This lens is white in the middle, tapering towards the two ends, whereas a concave lens is whiter at the two ends and it is narrow in the middle. So, just by touching a lens, you can come to know whether it is a convex lens or it is a concave lens. Number 1. The other thing is that lens is a transparent medium bound by two surfaces, of which at least one is spherical. Now the lenses which I have shown here, both the surfaces are spherical, but there can be a lens where one of the surfaces is spherical and the other is plane. Now this is bulging outwards, so convex. It can be like this. So concave and plane, convex and plane. It can be like this, convex, so concave. Okay, so we have different types of lenses. So we have different type of lenses, and you draw the lenses and you draw a lens like this, so much thick. And now you see this is the lens of a spectacle. So you can't even, see the bulge. So the lenses are not to be drawn too thick. Now, the lenses can be considered to be a combination of a glass slab and a prism. Now the two lenses are different because in this case, the tapering side of the prism is upwards, whereas it is inverted here. So this is the reason why the two lenses behave differently. That is, one is a converging lens and other is a diverging lens. Now I am going to show you, explain it to you. Now you see this is a lens and the ray of light coming parallel from air to glass. Okay? Rarer to denser. This is the normal, so it bends towards the normal. Okay? Now when it leaves this refracting surface, it is moving from glass to air, denser to rarer, hence it is bending away from the normal. Okay? You can also say that when there is a prism always bends the ray towards the base. Right? And prism always bends the ray towards the base. So in this case, the ray of light is converging, and in this case, the ray of light is diverging, moving away from the normal. Okay? So this is how the lenses behave differently. Okay? So this becomes a converging lens, that is convex lens, and this becomes a diverging lens, that is a concave lens. Then students, we know that this geometrical center of the lens, whether it is concave or it is convex, is called optical center. And we say that any ray of light which is passing through optical center like this, so we say it goes undeviated. But it is not actually so. It does suffer a very little negligible deviation, and for practical purposes we consider that there is no bending of light, no deviation. Now we come to that it is a transparent medium. So there are two foci, one on the left side and other on the right side. So we mention F1, F2, 2F1, 2F2. So what do we actually mean by F1? F1 is that point on the principal axis. If a beam of light is emerging from this point, it will always go parallel to the principal axis. So in case of a convex lens, the F1 we take on the left hand side and F2 on the right hand side. But in this case, the beam of light appears to meet here. Here the beam of light is actually meeting. Here the beam of light appears to diverge. So a convex lens is having a real focus, whereas a concave lens is having a virtual focus. So when we talk about refraction through the lenses, then we talk about different cases. We keep the object at different places. But what we notice is that in case of a concave lens, wherever you place the object, the image is always formed on the same side. It is virtual, erect and highly diminished. And there are two cases. Number one, when the object is anywhere placed on the principal axis, and then when the object is at infinity. So when the object is at infinity, then the image is formed at focus, virtual, erect and point size, highly diminished. And when the object is kept anywhere else on the principal axis, then the image formed is again virtual, erect, diminished, but it is between O and F. But when we talk about convex lens, when the object is at infinity, after refraction, the rays converge at a point called focus and real, inverted, highly diminished, point size image is produced here. Okay? And in case of a convex lens, the nature and size of the image depends upon the position of the object in front of the lens. Right? So students, in case of a convex lens, the size and nature of the image formed depends upon the position of object in front of the lens. If the lens is kept here and the object is at infinity, a real inverted, highly diminished image of the object is formed on the principal axis, and this point is called principal focus. Now, if we consider this as a lens, this is optical center, then this is 2F, then this is 2F. You know, lens is a part of a solid glass sphere, so 2F is the center of curvature of the lens, of center of curvature of the solid sphere of which the lens is a part. Now, if the object is beyond 2F, okay, now you see, by convention we take a ray of light coming parallel, so it passes through focus, right? And the other ray of light, I told you, the ray of light which comes through optical center, it doesn't deviate. So you see these rays meet here. So object beyond 2F, real inverted small image is formed between F and 2F, and then you can make it like this. Is it clear? Now let us have this lens, then F, then 2F. Students, if the distances are correct, equal, your ray diagram will never become wrong. Okay, so the next case is at 2F. So when the object is at 2F, the image is also formed at 2F. It is real, inverted, and of the same size. Okay. So real, inverted, and of the same size. So what you see is, as the object is moving towards the lens, the image is moving away from the lens and its size is increasing, right? And there is one case, in case of the convex lens, when the image formed is virtual, erect, and magnified. Okay, when the object is between O and F. Now you see, these are diverging rays which will never meet. So you extend it backward. And you see, you get virtual, erect, and magnified image. Now this is called, this arrangement is called simple microscope, hand lens, watchmaker's lens, palmistry. In palmistry, palmist uses this lens because it magnifies the small things and you get a virtual and erect image. But mind it, for this use, the focal length of the lens should be short. Shorter the focal length, more is the magnification. And with this, I conclude this topic of refraction through lenses with a note that a convex lens forms real as well as virtual image. Real image can be smaller, can be of the same size, can be magnified, but the virtual image is always magnified in case of convex lens. But a concave lens always forms virtual, erect, and diminished image. I hope you understood the lesson. Thank you.